Hi, welcome back. In this video, let me solve the questions remaining based on second order derivatives. I hope in my earlier video I have solved till 10th question from CBSE 12th book. So let me solve from the 11th question here. So the 11th question is, if y is equal to 5 cos x minus 3 sin x, y is equal to 5 cos x minus 3, then prove that dy square. So d square y by dx square is plus y is equal to 0. It is d square y, not prove that d square y by dx square plus y is equal to 0. Good. So the question he was given to us is, it is the 11th question from CBSE book, which is y is equal to 5 times cos x minus 3 times sin x. Prove d square y by dx square plus y is equal to 0. So first find dy by dx. Minus cos x derivative is minus sin x, so this becomes minus 5 times sin x minus 3 cos x. So d square y upon dx square is equal to dy dx of dy by dx, which is equivalent to minus 5 cos x, sin x derivative is cos x, cos x derivative is minus sin x, so this becomes plus 3 times sin x. Therefore d square y upon dx square is equal to minus of 5 cos x minus 3 sin x, which is same as y. So it implies d square y upon dx square is equivalent to minus y. Just bring minus y this side, it becomes plus y is equal to 0. Therefore d square y upon dx square plus y is equal to 0. Hence proved. Simple, right? Find the first derivative, then do the derivative second time, so that we get d square y by dx square. That is same as minus y, so hence d square y by dx square plus y should be equal to 0. Let me solve the next question. If y is equal to cos inverse of x, find d square y by dx square in terms of y alone. That's a good thing. Twelfth question. If y is equal to cos inverse of x, find d square y by dx square in terms of y alone. So from this, if I take cos on both sides, this becomes cos y is equal to x. Now differentiate this with respect to x, then I get cos y derivative is minus sin y into y derivative is dy by dx is equal to derivative of x is 1. It implies dy by dx is minus 1 upon sin y, or that is same as minus cosecant y. Now differentiate this function again so that we get d square y by dx square. So dy dx of dy by dx, that is d square y by dx square, is equal to minus cosecant y derivative is minus cosecant y into cot y into dy by dx. So this becomes cosecant y into cot y, but since I need answer only in terms of y, so I can replace dy by dx with minus cosecant y. So this becomes minus cosecant square y into cot y. That is same as d square y by dx square. I did get everything in terms of what is it? Y's. So answer should be minus cosecant square into cot y. Just go through this simple, do step by step, and you should be very good at the basic, that is differentiations of trigonometric, inverse, exponential, power rules. Then the questions are very simple, very simple. Y is equal to 3 times cos of log 4x plus 4 times sin of log x. Then show that x square times, we know that y2 is same as d square y by dx square plus x times y1 plus y is equal to 0. Okay. The question was, it is 13th question. If y is equal to 3 times cos of log x plus 4 times sin of log x, then I need to prove x square y2 plus xy1 plus y is equal to 0. Take this function, find derivative on both sides, so y1 is equal to minus 3 sine, because cos derivative is minus sine x, into derivative of log x, which is 1 by x, plus 4 times cos of log x into derivative of log x is 1 by x. I got something, I can take x to this side, so xy1 is equal to minus 3 times sine of log x plus 4 times cos of log x. Differentiate both sides again, so this becomes UV rule, that is derivative of x is 1 plus x into derivative of y1 is second derivative, which would be y2 is same as minus 3 sine derivative is cos log x upon x minus, because cos derivative is minus sine log x, so minus sine log x upon x, multiply with x this side, so this becomes x square y2 plus xy1 is equal to minus of 3 cos x plus 4 sine log x, which is equal to minus y, 3 cos log x plus 4 sine log x minus y. It implies x square y2 plus xy1 plus y is equal to 0. This should be the answer, hence proved. Simple, right? Just go by step and be a bit smart in between. Don't try to do derivative of sine log x by x. You might get the answer, it becomes too tedious. If you can just multiply it onto the side, it is x by 1, and then do the differentiation, the question becomes so simple, so simple. Next question, y is equal to a e power mx plus b and e power mx, then show that d square y by dx square minus m plus n into dy by dx plus m and y is equal to 0. Fourteenth question was, if y is equal to a into e power mx plus b into e power nx, Then I need to prove d square y by dx square, that is y2, minus m plus n into dy by dx plus m and y is equal to 0. So we have y here. So dy by dx or y1 both mean the same. A1 is equal to m into a into e power mx plus n into b into e power mx. y2 is equal to, again differentiate, that becomes m square into a into e power mx plus n square into b into e power mx. So now y2, let me take the question, m plus n, I need to prove this is equal to 0, right? y1 plus mn into y is equal to 0. So this becomes y2 is a into m square into e power mx plus b into n square into e power mx minus m plus n into, what is y1? m into a into e power mx plus n into b into e power mx plus mn into y. Y is a e power mx plus b e power nx. So if I simplify this, I get a m square e power mx plus b n square e power nx minus, if I expand this, I get m square a power mx minus mn b, this into this, this into this. So minus mn into b e power nx, similarly n into this and this into, plus, sorry, minus mn a e power mx minus n square b e power nx plus mn into a into e power mx plus mn into b into e power nx. So these two terms will get cancelled out, these two terms will get cancelled out, these two terms will get cancelled out, these two, so everything got cancelled out, so that is equivalent to 0. Hence proved. You can just go through this if you think you have queries. If not, we can just solve the next question. If y is equal to 500 times e power 7x plus 600 times e power minus 7x, show that d square y by dx square is equal to 49y. If y is equal to 500 times e power 7x plus 600 times e power minus 7x, show that d square y by dy square, this I need to show that d square y by dx square is equal to 49y. So take this, d square y by dx square is same as y2, right? So I'll just write y1 and y2. So y1 is equal to, derivative of this would be 7 into 500 into e power 7x plus minus 7 into 600 into e power minus 7x. y2 would be derivative it again 7 into 500 into e power 7x plus minus 7 into 600 into e power minus 7x. So y2 becomes 7 square into 500 into e power 7x. Minus into minus 7 would be again 7 square into 600 into e power minus 7x. I can take 7 square common. If I take 7 square common, I get 500 times e power 7x plus 600 times e power minus 7x. This is same as y. So this becomes 49y. Hence y2 is same as d square y by dx square, which is 49y. Excellent. Let us solve the next question. If e power y into x plus 1 is equal to 1, then show that d square y upon dx square is equal to dy by dx whole square. If e power y into x plus 1 is equal to 1, show that d square y by dx square is equal to dy by dx whole square. E power y is given as x plus 1. I need to show that d square y upon dx square is equal to dy by dx whole square. So from this I can write it as e power y into x plus 1 is equal to 1, right? Yeah, e power y into x plus 1 is equal to 1. Yeah, then I need to put this. Okay. I can write this as x plus 1 is equal to 1 by e power y. That is same as e power minus y. Now differentiating both sides with respect to x, derivative of this would be 1 equal to e power minus y into derivative of minus 5 with respect to x. So it implies 1 is equal to e power minus y into minus 1 into dy by dx. So it implies dy by dx is equal to minus 1 upon e power minus y. That is equal to minus e power y. So I got y1 as minus e power y from here. So y2 would be minus e power y into dy by dx. So minus e power y can I replace with dy by dx? So dy by dx into dy by dx, which is dy by dx whole square. So y2 is same as d square y by dx square. So therefore d square y by dx square is same as dy by dx whole square. Very good. Next question. If y is equal to tan inverse of x whole square, then I need to show that x square plus 1 whole square into y2 plus 2x into x square plus 1 y1 is equal to, don't get afraid by saying such a big terms. Nothing, just to go through the basics which we know, we can happily solve the questions. If y is equal to tan inverse of x whole square, show that x square plus 1 times y2 plus 2x into x square plus 1 into y1 is equal to 2. So take this y is equal to tan inverse of x whole square. So y1 would be 2 times tan inverse of x into tan inverse of x derivative would be 1 by 1 plus x square. So multiply this onto the other side. So this becomes 1 plus x square into y1 is equal to 2 times tan inverse of x. So if I derivative this again, derivative of UV rule, 2x y1 plus 1 plus x square into y2 is equal to 2 into 1 upon, I think this is x square plus 1 whole square, yeah. So 1 plus x square. So you multiply this onto the other side again. So this becomes 1 plus x square whole square y2 plus 2x 1 plus x square y1 is equal to 2. Hence proof. Okay. We are done with all the questions that are related to second order derivatives. So we are done with most of the topics. In my next videos, let me solve some questions based on all these concepts, bit difficult questions. Then I need to explain about Rolle's theorem and mean value theorems. So then we are done with the differentiation. Okay, go through all these videos perfectly. I think differentiation would be definitely the easy topic. Okay, see you in the next video. Bye till then.